All right, ladies and gentlemen, today's video is going to be on triangles, the different types of triangles, how to find missing angles in some of these triangles. So it should be a pretty easy lesson. So the first thing I'm going to do is talk about the different types. Well, triangles, before we even go there, triangles are what we call polygons with straight lines, of course, three sides and three angles. And when we talk about how to classify them, we can classify them by sides. And the way we can classify them by sides, we can have no sides equal in the triangle. That would be a scalene. We can have at least two sides equal. That would be your isosceles triangle. And I'll show you in a minute, if you have two sides equal, you're also going to have two angles equal. By the same thinking, scalene is not going to have any angles equal. And then the other one we have, we have our equilateral. And that is all three sides equal. Okay, we can also classify these triangles by angles. So one way to classify them by angles, probably the most common one we see is our right. So the most common one we see is our right angle. And this one has to have at least, or no, sorry, let's not say at least. It's going to have only one right angle. Because if you think about it, the one thing that we know about all triangles is the interior angles add up to 180. So that's why it can only have one right angle, because if you had two right angles, then you would already have totaled 180 and your other angle, would have to be 0, which doesn't happen. So that's why it has to have only one right angle. And then the other angles, of course, are going to both be acute. We can also have an acute triangle. Speaking of acute, that would have all three angles less than 90 degrees. That's what acute by definition means. And of course, a right angle means 90 degrees if you didn't know that already. And then, so when we're looking at this, well, let's get the last two. We could have an obtuse triangle. I can spell today. And that would be only one angle greater than 90 degrees. By the same reasoning that we couldn't have more than one right angle, we can't have more than one angle over 90 either, because it's going to make our, sum up to too much in the triangle. And then we also have what we call equiangular. And that would be all angles equal. So when we talk about classifying, you can say, I have a scalene right triangle. You could say I have an obtuse isosceles triangle. So you actually can, and if we have an equilateral though, it's got to be equiangular. All sides equal is going to mean all angles are also equal. So these two can't be interchanged with any other words, but we could have a right scalene, a right isosceles, things of that nature. Okay, what we concern ourselves, mostly with triangles is trying to find the missing angles inside of a triangle. So let me go to the next page and make you up an example of how to do that. Okay, so let's just take a right triangle to start. So these are just examples of finding missing angles inside of the triangle. And it does have to do with the fact that the interior angles sum up to 180. So if this is my triangle, this box implies 90 degrees. And let's say I give you this angle is 20. Well, you can add up 90 and 20 and get 110 and then subtract 180 minus 110 to get 70. But if you think about it, if we know the interior angles add to 180 and 90 is already used up, that leaves these two angles have to be complementary. They have to add to 90. So 90 minus 20 would be kind of a shortcut way to get that missing angle right here. So that missing angle in that triangle would be X. We could have a isosceles triangle. Let's look at an isosceles triangle real quick. So remember, the isosceles triangle has at least two sides equal, and we're going to make just two sides equal. Those markings mean two sides are equal. And in the isosceles triangle, there's actually three different ways you could be posed a question. I'm going to do all three. Let's take the easiest one first. Again, this is isosceles. All three of the next examples will be isosceles triangles. So if I tell you this is 50, and I want to know, let's just start with that, the easy one. If I tell you this is 50, well, the two angles that are, the two sides that are equal, the angles that are equal sit across from them or at what we call the base. This is called the base of the isosceles triangle, and this is called the vertex angle. And the vertex angle is where the two equal sides meet, and the base is the non-equal side. Now that triangle could be turned around, twisted around. I'll twist it around in some other examples. But the reason these words are important is I've seen them actually not give you a picture here and only say words, and you had to go reproduce a picture for the word. So make sure you know that the vertex angle is where the two equal sides meet, and the base is the non-equal side of the isosceles triangle. Well, these base angles, we call these base angles. Let me just write that out here to the side. So the base angles are equal to each other. Remember, two sides equal is going to make us know that we have two angles in here equal as well. So what you can do is just say X is 50 degrees and you're done with that problem. And many of the problems we see in geometry, as long as you know the idea or the concept, you don't have to do a lot of math. It's just knowing those concepts. All right, let's look at another isosceles triangle. Okay, if I tell you this is 70 and I want to know this. So I hope you see that this is going to be different because this is the vertex where the two equal vertex angle. And this is the base. So the answer is not 70 because I didn't ask you for the other base angle. I asked you for the vertex angle, but you can put in the fact that this is also 70. And then you can kind of do what we did with that right triangle a minute ago, or what we could do with a triangle like this. We know that we have two numbers in the triangle already that total up or sum up to 140. I know the whole triangle has to equal 180. So 180 minus 140 would give me 40. And you can always check after you get the answer and make sure those three numbers do add up to what you know it has to, your 180. Let's do one last isosceles triangle. And you see how I purposely turned this on its side? This one's actually turned upside down, so you can still understand where the vertex angle is and then where the base is, so you know where those two equal angles are. This one, I'm just going to say, I don't know, 80 right here. No, let's not use 80. Let me use a different number. Let's use, let's just use 20 right here. Okay, so if that vertex angle is 20, then that means, now these are the ones that are equal. So I've used up 20 out of my possible 180. That leaves me with 160, but that's not the answer. If I say X here, that's not the answer because 160 has to be split between both of those angles. So when I split it and get 80, that's going to be my correct answer. It'll be 80 over here and 80 over here. Again, if you add those three numbers up, you would get 180. Okay, another important thing when we talk about these triangles is they can actually draw you a triangle. Draw a triangle. And they can actually extend out one side or more sides of the triangle. And so let's say that this amount is 70 and this amount is 80, and they want to know this angle right here. So we we are going to use 180 like we did before, but it's not going to, you can't mix together the inside and outside of the triangles. When you're using the fact that the triangle, the angles add up to 180, it's only these 1, 2, 3 interior angles. But you can still treat it like we did a minute ago. 70 plus 80 is 150. And 180 minus 150 is 30. That would go right here. And then we have a straight line that always makes 180. So you could do 180 minus 30 to get 150. So this angle would be 150. And if you notice, these two numbers added up to be 150 to start with. Well, that's what we call a shortcut. I always tell my students it's okay to work it the long way. If you forget the shortcut, you'll have so much to memorize in geometry that I feel like doing this one the long way is not that terrible. But it is a shortcut if you'd like to memorize it. Here's another one, kind of similar, but not similar. So if I tell you this angle is 100, and I give you 80 here, and X, you might correctly assume that we could do the opposite of what we did up here and subtract these numbers to get this answer, this angle of 20, and you'd be correct. But let's talk about how it would work the longer way around. If this is 100, 180 minus 100 would give me 80. So this angle would be 80. And then you could think about now the inside angles. 80 plus 80 is 160. And we know the whole triangle has to add up to 180. And that would give me the 20 degrees that I know goes right here. But like I said, you could use that shortcut. It works really well. We could take this outside. It's called the exterior angle theorem because that's what it is. These are exterior to the triangle. And if you, what the theorem says that if you, adjacent means connected to. So it's not going to be this angle that you're dealing with if you're doing the shortcut. It's these two that aren't connected to this outside angle. They will always add up to be this angle. So think about it. 80 plus 20 does add up to 100. But like I said, it's perfectly okay to go about this in the long way. All right, now before I leave on this video, folks, there's a lot more videos about triangles because in geometry, we work on just finding missing angles. We work on classifying. We've already done that, but we're also going to be working on some Pythagorean theorem with these triangles and some congruency with triangles. So please make sure you go look up some of the other videos that has to do with triangles because there's much more to learn about them. And I'll see y'all on the next video.